Hi everyone, Adarsh here from Adarsh Model Train. So it's a video, awaited video for the long time because I was busy in some other works. I was building some other softwares for our model layout. So I was busy in that. So that's the reason I was not able to create a video. But let's jump into the video. So today what we're gonna do is we will try to configure Snap Turnout, Servo Turnout, LED, signal, light, everything together in the single node. So this is the last and most complicated configuration for a node which we can have. So first we will see with the MQTT and later we will see with REST API the same configuration. So first we have to go into our github.com with github.com/adarsh-model-trains, and once we get into the repository we have to go into Jmri Mqtt Spring Transformer wireless ecosystem. Once we get into this, so here we can see in ESP Arduino solutions, and here we have two type of implementation. One is servo snap turnout signals with MQTT, REST servo snap turnout and signals with REST protocol. So first we will see with MQTT. We will go into that and we will download the source code. I'll download the source code in my desktop. And let's extract the code. So here already there are three pieces of code. One is for Arduino, one is for ESP, and one is for getting the calibration number for the servo turnout. So first we will upload the ESP. First we will upload the Arduino code. So let's get into that. Play into this. So here we can see our code is there. So first we have to go into config, and in the configuration we need one servo board, one snap turnout board, we need only one light board, and total number of boards we need I guess 3 boards. And here we will give number like 1000 that you can derive from the calibration sketch. So I'm not gonna do any changes here. In the earlier tutorial I have already shown how we can get the calibration numbers for open and close for the servo based turnout, and those numbers we have to copy paste here. So I guess this is what we have to do. And slow moving true, LED type anode is false. Let's make it true, and that's it for this. So let's connect the, so I have here ESP82 as well as Arduino Uno. I'll connect Uno here first. And let's go to the, so port is correct, board type is correct, so we can just compile this code. First we will do the dry run, and then later we will see with all type of configurations. The compilation is done, and let's upload the code. So uploading is done. So in the default configuration I can see 11,500, 5,200. So that's a baud rate. Let's open this. 11,000 here. So here we can see total number of servo turnout board 1, snap turnout board 1, light board 1, servo turnout, snap turnout, and light and signals. Address, so we need 3 board for address number 40, 41, 42. So we are good with this. Let's close this and go into ESP code. Just go to configuration here, config.h file. See here, everything is good. Password for MQTT. This is the topic name. This is the Wi-Fi information. That is good. Let's connect to go into boards in Node MC 1.0 and go into port. Let's compile the code. There is no change required in this. You can change your Wi-Fi ID and password here, your MQTT server username password there, and if you have changed the topic name, you can do the change here. And this is a client ID for this node. If you are having some custom one, you can change it here also. So it's compiling the sketch. Let's see, it's on 11,000. Okay, so there are two configuration. One is default config, which you should not change, and one is config where you should do the changes. Compilation is done. Let's upload the code. So I guess it should be able to connect to the Wi-Fi, but after that it should not be able to connect to the. Compilation is done. Let me upload once again. I guess every time I'm just pressing the compilation button, not the upload button. That's the reason it took time. I didn't realize that. So now code is uploading into ESP. So it should be able to connect to the Wi-Fi, but not with the MQTT queue, because we have not started yet. See, connected with the Wi-Fi. It should say not connected to MQTT. Yeah. So that's fine as of now. We are good with this. Let's close this, and what we will do, we'll just start the MQTT, Jmri and Spring Transformer application first, and we'll do the dry run, and then later we will test with other things. So now what we will do, we'll just start the Jmri first. Sorry, MQTT desktop, MQTT config Python start. So our MQTT has been started now, and in the new tab cd dot we'll start the Spring Transformer application. So to start the Spring Transformer application, we have to get the configuration, basically the command to start that. So we'll go into that, and we'll go into Spring Transformer readme page, from where you can download the jar file and configuration file, and you can do the changes. If you are following me since from the first video, you will know, you will be very well aware of how we can do all those things. So here's a command, but before that, let's verify whether the configuration whatever we have, it's correct or not. So here we'll see. We are running the prod profile, that's correct. We have to go into nodes. Node number 1, enable. Publishing is enabled to MQTT. REST API is also enabled. Light count, we need 1 light. 2 LED signal, we need only 1. 3 LED signal, we need only 1. Servo turnout, we need only 1. Snap turnout, we need 1. Total number turnout board, we need 2. 1 for snap, 1 for servo. This is because snap and servo turnout, if you are configuring together, it will configure on the 2 different boards, not on the single board. And light board, we need 1 because all the lights work on the same PWM frequency, but servo and snap turnout work on 2 different frequencies, so every board can configure only 1 frequency for whole 16 pin. So that's the reason we need 2 different board for turnout here, but for the light we need only 1 board. And this is a topic where Jmri will publish, our Spring transformer will publish the data after transforming all the information. So we are good with this. Let's save this, close this, and run this application. So here we can see here one server will spin up. This folder will be created locally. So now what we can do is we can just go and see the configuration what we have configured till now. So we can use this. It will give all node information here, whatever the nodes we have configured till now in our system through the configuration file. But I'm interested only in node 1, so I'll say 1 node ID, and I'll get the first only. Node ID is 1, enable is publishing, node is enabled, publishing is enabled, REST API is also enabled. Light address start from 10,000, I need only 1 light. 2 LED signal start from 20,000, I need only 1 count. 3 LED signal start from 30,000, I need only 1 count. Servo turnout starts from 40,000, 1 servo turnout is configured. Snap turnout address starts with 50,000, I need only 1. 2 turnout ports, 1 light board, and node topic which we are subscribing from ESP is this topic, which is emt/node/node ID /data, and all these are like total number of light pin we need 1, total number of signal 2 LED signal we need 2 pins because we need 2 pins, and 3 LED signal we need 3 pin for servo. Total number of servo turnout pin we need only 1, total number of snap turnout pin we need 2. So this 2 LED pin is 1 for green, 1 for red. This 3 pin is red, yellow, green. Servo turnout we need only 1 pin, PWM pin, and snap turnout we need 2 pins. For light we need only 1 pin so that we can pass on off signal. So here if you see total number of board required, if you can validate your configuration here. Total number of servo board required is 1, total number of snap turnout board required is 1, total number of light and signal board required is 1. And how you have to configure in Jmri address for turnout 40,001 for servo number 1, board number, pin number, status. So board number 0, pin number 0, it will send throw as well as close signal. If you see Jmri snap turnout at Jmri address 50,001, board number, pin number, status. So board number 1, pin number 0, board number 0, pin number 1, it will send a close signal, and for board number 1, pin number 0, it will send a throw signal. So that's the reason we need 2 pin here. Earlier we have discussed here for snap turnout. And for light, Jmri address 10,001, board number 2, pin number 0. Jmri here for 2 LED signal, Jmri address 20,001 and 20,002, board number 2, pin number 1, it will send on and off signal, board number 2, pin number 2, on and off signal on the same pin. And if we see the 3 LED signal here, Jmri address 30,001, 30,002, 30,003, board number 2, board number 2, board number 2, and pin number 3, it will send on and off signal for red. For green it will send board number 2 pin number 4, it will send on and off signal. For yellow pin it will say board number 2 pin number 5, it will send on and off signal, and Jmri address for corresponding to that LED is this. So each and every detail we will get in our this endpoint will give you how you have to configure in Jmri and how you have to configure it in PC9685 board. So that's how it will make your life easy. There will be no confusion. If you just follow these instructions, you'll never go wrong. So let's do one thing. Let's configure this thing together and then get the other boards and all and do the testing. So in the earlier section, what we have seen, how we can get the configuration using REST API. So we have seen all these, we have gone through all these things. Let's go through the configuration first. So here you can see, here we have ESP8266 node MCU, where it is powered from the Arduino Uno. So this red wire is a 3-volt power supply, and this brown one is a ground which is coming from Arduino, and this white and black is RX TX pin. So RX from node MCU will go to TX of Uno, and TX of Uno will go to RX of node MCU. So this is how the node MCU and Arduino Uno is talking to each other. And then next we will see, here we have 3 boards, board number 40, board number 41, board number 42. So here you can see it is connected here via Arduino Uno. So this yellow and orange is a SCL and STA line, serial clock and serial data line, and this red and brown is a 5-volt power supply and GND, which is going to first board here. In the first board, here you can see, so from the first board it's chained here, all the 3 boards. So here you can see in this breadboard, this is external 5-volt power supply which is coming from external adapter, which is going. So for every PC9685 board we need 5-volt as well as GND. So here you can see, this is blue one is a GND and this white is a 5-volt power supply. So all the boards are taking from this breadboard here, and here you can see this plus and minus is coming from other side of the board. So first thing what we have done is, here let me connect this external 12-volt power supply also. So from the board 1, if you see our configuration, from the board 1, board 0, pin number 0. So if you see here, board 0, pin number 0, servo, turnout. Then if you see the next one, snap turnout, board number 1, pin number 0. So here you can see, from board number 1, pin number 0 and 1 is going to the relay switches here to control the throw and close position, and this relay switch is powered by 5-volt and GND, which is taking from this breadboard here. And here you can see this, to control the snap turnout you need external 12-volt power supply. So this is coming here, and from this 12-volt from this breadboard it's going to this middle pin, which is a common, so that both the throw and close position through both the relay switch will be active. And if you see this black one and this white one, so this which is glowing always, that is the off state of the relay switch. So here for this if you see here, this black and white, and this white is always glowing. So never put your turnout wire into this which is always glowing. Always use the opposite one which is not glowing. And here if you see in the another one, you can see gray and white. So here red one is always on, and this red is off, this gray one is off. So which is glowing, never put your turnout wire into that. always put into the opposite one. So what will happen, whenever the turnout is on, it will go for 1 second here for some 60 millisecond, and it will go back to this. So meanwhile it will power up this, and it will do the change, and it will go back. But if you put your this wire into there, this will burn the solenoid of this will burn this turnout. So that's how you can figure out that which way you have to configure your snap turnout via relay switches. And let's come to the light part. So if you see the light, first here we can see light number, board number 2, pin number 0. So this is 0, 1, board number 2, pin number 0. So if you see this orange, this is also connected to one relay switch. This is a single relay switch. So here this relay switch is powered by this black and brown wire, which is taking 5 volt from this breadboard, and this orange wire is from the pin number 0 to control the on off position. And now what we will do, you will just connect your, you will give your power main for the light, you will give it into this plug, and you can just give the on position here. So whenever this is on, it will take the power and it will start your light there. So this is how you have to do the light one. But now let's talk about 2 LED signal. So if you see 2 LED signal, board number 2, pin number 1, and board number 2, pin number 2. So red one we have to configure on pin number 1. So if you see here, these are the two. So red one, this yellow wire is going to the second, on the board number 2, pin number 1, and this green one is going to pin number 3. And this is how we are controlling the 2 LED signal here. And same thing for 3 LED signal. If we go into 3 LED signal here quickly to the, so 3 LED signal, board number 2, pin number 3, board number 2, pin number 4, board number 2, pin number 5, red, green, yellow. So first we have to configure the red one. So here you can see the orange is for red, yellow is for yellow, and green is for green. So how we have to configure, first one should be orange, which will be the third pin for the second board. Then you have to configure green on the pin number 4, and then you have to configure pin number yellow light on the pin number 5th. And this is how we have to do the configuration. So this is how you can always avoid to burn your this turnout. You can make sure your servo is also mounted, your all the configuration is configured. Now in the next section what we will do, we will just test it via Jmri. So we have already gone through the configuration of this, how we have connected. Now what we will do is, we will just make sure everything is inside the I don't have too much space in my table now, so I have to adjust everything here. So what we will do, we will just open up the Jmri. So here we have Jmri. We will go to tool, table, turnouts. First we will see the snap or servo turnout. So this is the 40,001. If you see here, servo turnout 40,001 on Jmri address. So this is a 40,001 Jmri address. So let's throw it. So here you can see it moved. I have not stick it to the table so that it will move whole turnout, but because we have not got the proper calibration numbers for throw and close, but just for the demo purpose I am just showing it. But if you are following this video tutorial from the start, you know how to do the calibration as well as configure the turnout with the servo. And this is how the, and if you want to see here you can see the what our Arduino is getting, Uno basically. So you see here. So this is how we are getting through, and if you will say close, so I'll just increase this thing and then I'll show you. So this is how the servo is working. Now let's go to the snap. For the snap turnout 50,001 Jmri address, so we'll go to 50,001 here, and you can see here in this, as I told, it will go flick here and then come back here, and it will go here and come back here. Just so you can see now blue one will work. So I'll just make it little bit bigger so that you can see here. So you can see red will come here and then go there again, and this turnout will change its position. And here if you go to blue one, sorry, I just changed this. Okay, you have to see here the blue one. Now again it will be red one, and then again it will be blue one. So this is how we can do the configuration for servo based turnout and snap based turnout using relay switches in the same node. This chain we can keep going on up to 64 boards, so there is no limit. 64 board is like 1000 something address you will get. So after this, what we will do, we will go to the light first. So for the light, what we have, 10,001 address on board number 2, pin number 0. So we'll go to here L1 here, this one, and you can see here this relay switch should work. So here you can see light number 10,001, board number 2, pin number 0. Here we'll go to lights and we'll see here this one. So this will say on, off now, and once it's on, so it's on. So I'll just increase the screen here and I'll show you this one. It's off now, but it's on. So in this one, this point, you have to put the middle one, you will pass the common, you will pass the power supply, and this one you will take it to the light. So this is how the light can be tested. So now we'll go to 2 LED signals. So 2 LED signal on Jmri address 20,001 and 2, and board number 2, pin number 1 and pin number 0. So this is the 2 LED signal here, board number 2, pin number 1 and 2. So here you can see 2 LED signal here, board number 0, 1, 2, board number 2, pin number, already pin number 0 is this light, 1 and 2 is for red and green. So let's go to the signals, signal head here. So here you can see 2 LED signal, we'll say red. So red is on, we'll say green, green will be on. I'll show you in this. So once we go into signal head, we can say red. So you can see red will be on in this, and if you say green, green will be on. I'll just increase this again, once again. It's like a red, and it's like green. And here you can see all the information you can see in the Arduino Uno console. So but if you make it yellow, so both the things should work. That's what my expectation is here. So if you make it yellow, both should work, because it's assuming that for yellow you are using RGB LED, which has, if you just glow red and green, then it will turn into yellow. So that's how it is. That's how basically the 2 LED. And now let's go into 3 LED. So if you go to 3 LED here, 3 LED signals we have configured: 30,001, 30,002, 30,003, board number 2, pin number 3, pin number 4, pin number 5. So, and on off will be on the same pin. So let's go to this one, and I'll show you here. So let's make it red. So this should work. So red is working. Let's make it yellow. Middle should work. Yep. And let's make it green. Green is working. I'll just make it more. So if you can see, I just made it dark. So let's make it red. Red is working. Yellow, middle one should work, and then make it green. So now green is working. So that's how we can do all this testing here. And this is how we have to configure each and everything. And if you see the serial monitor of Uno, you can see all the information which is passing here. And other than that, what you can do, you can just use the MQTT QTTX app, which I already, in the previous tutorial I already showed you that how we can use that. So here, so if you use this one and if you say connect, it will get you all the messages which has been published from Jmri as well as all the things. So there are many options, but today I just want to make it simple, so because it's already very complicated thing. But this is how we can configure a single node with Snap Turnout, Servo Turnout, 2 LED, 3 LED lights, and with this chain you can configure 64 board, and every board is having 16 pins, so there's no limit on that. And in our system you can configure, I have tested till 12 nodes, so every node can have 64 boards, so you can have endless limit of configuring your all your signals, LED and lights and turnouts, whether it's a servo or Snap Turnout, you can configure it. So it's very good stuff. That's what I feel, because I want something which should be very expandable, and with this endpoint you will get exactly help how you have to configure which board, which pin, and what Jmri address you have to use. So that's it for now. See you in the next tutorial. Thank you.